Howdy. So I'm going to go over the root enable for PXE cluster data store code here that I've created. This implements the root enable for Percona cluster. Also does a little bit of refactoring from what we have for the Vertica root enable right now as well. So the first thing here we go into is there's a new config controller, or a new root controller config for the Percona cluster data store. I change it from the Trove Extensions Common Service default root controller to default root to cluster root, and I'll explain a little bit of that later. This change is only on the Percona XtraDB cluster currently, since the two clusters that we have right now are Vertica and Percona cluster now, so we're enabling that for this. So we have here is there was a cluster root object to create this for a cluster rather than just a single instance. This was originally in Vertica root, and I've actually moved this to a common place because it can be used across other data stores as well. This basically just creates a root user calling for a single instance. And since it's given an instance ID and possibly a cluster instance list, then for each one of those cluster lists, we go through and actually create a root history object saying that it's created, since we're initially only creating it on a single instance. And that's above here where we actually create. We do the create, but we don't actually handle the cluster list instances in the single root object. So here we're actually handling the rest of those. And then this is a cluster root controller. This was actually originally in the Vertica root controller as well. This was moved over. This is basically a copy and paste of exactly what Vertica had, but the only difference here is the get cluster instance ID, and this returns the single instance ID for either the master node in the instance and then the list of instance IDs. With that, we're able to know what instance to actually call a single root create on, or test a root create on, or across all the other instances. Then this is the Vertica models, like I was saying. It was called Vertica root. This was the create call. Move this over into the common. This is the Vertica root controller, which, as I said, we moved. This was the copy and paste move over of all this code. The only thing I left here was the cluster instance ID, which in Vertica's case needs to get the master type of instance. If all of them are member instances, like in the Percona XtraDB cluster case, then we can use the default the default one that I have for the cluster root controller. In Vertica's case, it needs the master, so we actually need to pull the master instance rather than just any single instance. Then we have a enable root password. This is in the guest agent for the Percona cluster manager. We're adding this because it didn't exist before, so we needed to make sure we enable with root given a password, or if it's not given a password, then the same method can be called and it will enable a root password and generate it on the guest agent side and return that back to the user. Here this is a scenario test that I added for the cluster actions. We have cluster root enable right after we build it. We create a cluster, add some data to it, and then we test enabling a cluster. We verify that it's enabled, and then after a grow, we verify that it's still enabled. After the shrink, we verify that it's still enabled. And these are the other parts there to make sure it runs in order. Here in the MySQL helper scenario testing stuff, we set a root name and or the name for the root user, which is root, and the password, which is root pass, so that we can reuse this throughout the other test. We have here, we grabbed those root credentials and we're actually using them. Added a method to create a root client. This will grab the root connection string rather than the regular connection string to build, and we're building the user and password into this with the credentials.root, so that we've grabbed up at the top. At the bottom here we have a test root connection. This actually creates a root client that we have identified up here, and basically makes a simple select statement so that it verifies that that's a good connection. And we use this throughout the test for the verify root is enabled. Here, this is a test helper class. This is what is extended from the MySQL helper, the test helper, just to make sure if you don't have this method and we need it, we have something default set so that it's overridden from the MySQL helper. Here we actually have the runner part of the scenario test, run cluster root enable, which grabs the root credentials, calls the client, calls client.root.create cluster root with a cluster ID and the root credential password, and that's all you need from the client side to enable root for a single instance or a cluster. This verifies that that call was made correctly. Then we have a run verify root cluster enable. This makes the API call to test if the cluster is root enabled on that cluster. We assert that that value comes back as root enable is true. Then we grab that cluster and we make a test connection from the password that we know, and on one of the single instance IPs of the cluster. Since we're building out the root credentials, we also added a new root definition here for the build helper defs. I'll get a little bit more into that, but it's coming back as 3 values in the tuple instead of just 2, so added that. Here's where we build the helper def, and this now returns the root credentials. I moved this code that actually grabs the credentials into a helper method that we can use across all of or between the 2 helper credentials, which is for the regular user and the root user. So we grab those and we can then return the database regular user and the root user credentials. Same kind of thing up here where for the test helper on an instance, this is what this was doing, was creating the database and user once an instance is created so that we can verify things, verify that data can be loaded and that the user and database exist. This also adds the root definition. If root definition in this case is not enabled on a single, because this is for a single instance, it's not actually used at this point, but rather in a separate test. So we have some unit tests that I added here as well. So the common extensions for the root controller stuff had no unit tests, so I added a ton of unit tests for the default root controller. Added some tests for that. Root controller, which was already there as well. Both of those were there. Added some unit test around that. The cluster root controller that I had just added in this, I added a test around that as well for all the methods. Here in the guest agent for the PXE manager, I added the test for the test enable root with password, which basically checks that we can create a password and validate that it's working. Also, one minor change here is that I changed everything from magic mock to mock, which shouldn't matter, but that was common across some of the other tests that I had, so I felt more comfortable with that. Here we've in the unit test, task manager, test models. So this was the cluster root model that I created in the common location from the Vertica stuff, and move this into a test that validates the create. Make sure that it creates correctly. And that's pretty much it. With that, I've been able to run through all the tests here. You can see the cluster actions here. We have root enable after create, and then we verify root, as well as after a grow we verify root again, and then after shrink we verify shrink again. And once we have the grow and shrink, these tests will not be skipped anymore, because we don't have that spec hasn't been merged yet either. So that kind of wraps it up. Just wanted to give a little quick overview of what's going on with, or what the code looked like for the root enable for PXE data stores, and hopefully that'll help. Thanks.